Welcome. Thanks for joining us. Could you briefly introduce yourself?
Thank you for having me. I'm Ethan Miller, a machine learning enthusiast with hands-on experience in Python, data preprocessing, and building small end-to-end ML projects. I enjoy solving real-world problems using ML, and I'm excited to grow through industry-level challenges.
How would you explain machine learning in simple terms?
Machine learning is a way for computers to learn patterns from data instead of being explicitly programmed. Once trained, models can make predictions or decisions on unseen data.
Can you describe the main types of machine learning?
Supervised learning uses labeled data, e.g., spam detection. Unsupervised learning finds patterns in unlabeled data, e.g., clustering. Reinforcement learning learns through rewards and penalties.
How do you explain overfitting and underfitting?
Overfitting. The model memorizes training data and performs poorly on test data. Underfitting. The model is too simple to learn underlying patterns. To reduce overfitting, I use regularization, dropout, early stopping, or collect more data.
Why do we need a train/test split?
Because we want to evaluate how well the model generalizes to unseen data. Training teaches the model. Testing checks performance on new data.
Which metrics do you commonly use?
Classification, accuracy, precision, recall, F1 score, ROC-AUC. Regression, MSE, RMSE, MAE, R-squared. I choose metrics based on the problem. For example, recall is crucial in medical diagnosis.
What is feature engineering and why is it important?
Feature engineering transforms raw data into useful inputs. Better features often boost model performance more than complex algorithms. Techniques include encoding, scaling, normalization, and deriving meaningful domain-specific features.
Can you explain gradient descent?
It's an optimization algorithm that adjusts model parameters to minimize the loss function. We calculate the gradient of the loss and move in the direction that reduces error.
How do you tune hyperparameters?
Grid search for detailed, exhaustive search. Random search for quick exploration. Bayesian optimization, or Optuna/Keras tuner for efficient tuning. I usually start with random search to find good ranges, then fine-tune with grid search.
What is the difference between CNNs and RNNs?
CNNs handle spatial data like images. They capture local patterns using filters. RNNs work on sequential data like text or time series. They keep a memory of previous inputs. Variants like LSTM and GRU improve long-term learning.
How do you handle missing data?
Remove rows/columns if missing values are small. Impute using mean-median mode. Use advanced methods like KNN imputer or regression-based imputation. The method depends on the dataset size and distribution.
Which ML libraries are you comfortable with?
Data, pandas, NumPy. Visualization, Matplotlib, Seaborn. ML, scikit-learn. DL, TensorFlow/Keras, PyTorch. I've also used OpenCV for image processing.
Can you describe a project you worked on?
I built a plant disease detection model using CNNs. I collected the dataset, did augmentation, trained the model with Keras, optimized with early stopping, and deployed using Flask. The model reached about 93% accuracy.
Why are you a good fit for this internship?
I have solid 1050 fundamentals, hands-on coding experience, and a strong desire to learn. I adapt quickly, collaborate well with teams, and I enjoy solving complex problems. I'm confident I can contribute to meaningful projects while continuing to grow.
Can you explain the bias-variance trade-off?
Bias is error from making overly simple assumptions. We aim for a balance. Low enough bias to learn patterns, and low enough variance to generalize. Techniques like regularization, simpler models, and more training data help manage this trade-off.
What is regularization and why do we use it?
Regularization penalizes large weights to prevent overfitting. L1, lasso, adds absolute value penalty. Right pointing arrow can make weights 0, feature selection. L2, ridge, adds squared weight penalty. Right pointing arrow reduces weights smoothly. It improves generalization and stability of models.
How does cross-validation work?
Cross-validation splits data into k-folds. The model trains on k1 folds and tests on the remaining one. This rotates until each fold has been used for testing once. It provides a more reliable performance estimate than a single train test split.
Can you explain bagging versus boosting?
Bagging, bootstrap aggregating, trains multiple models independently on random subsets to reduce variance, e.g., random forest. Boosting trains models sequentially, where each model tries to correct the previous one's mistakes, e.g., XGBoost, AdaBoost. Boosting usually gives higher accuracy, but is more prone to overfitting.
Explain how a decision tree makes decisions.
A decision tree splits data based on the feature that yields the most information gain or highest G&E impurity reduction. It continues splitting until reaching pure leaves or a stopping condition. It's interpretable but can easily overfit without pruning.
Why do we use normalization or standardization?
Because models like KNN, SVM, and gradient descent-based algorithms are sensitive to feature magnitude. Standardization, x minus mean / STD. Normalization, scale values to 0, 1. This helps the model converge faster and improves performance.
What is the difference between probability and likelihood?
Probability. Given parameters, what is the probability of data? Likelihood. Given data, how likely are specific parameters? In ML, likelihood is used in model fitting, e.g., maximum likelihood estimation.
What techniques do you use in natural language processing?
Tokenization, stop word removal, lemmatization / stemming, TF-IDF, or word embeddings like word2vec, glove, transformer-based models like BERT for NLP classification tasks. I typically start with TF-IDF plus logistic regression or LSTM / BERT for more complex data.
How do you deal with imbalanced datasets?
Resampling, oversampling, smote, or undersampling. Class weights, assigning more penalty to minority classes. Appropriate metrics, F1 score, ROC, AUC, precision recall, AUC. Ensemble methods like boosting. These approaches help prevent the model from ignoring minority classes.
Why do we use activation functions in neural networks?
Activation functions introduce nonlinearity. Without them, neural networks would behave like linear models. Common ones, ReLU, sigmoid, TAN. ReLU is widely used because it's simple and reduces vanishing gradient problems.
What does the softmax function do?
Softmax converts a vector of numbers into probabilities that sum to 1. It's used in the output layer for multi-class classification.
How would you deploy a machine learning model?
I typically save the model, pickle /ONNX /saved_model. Build an API using Flask or Fast API. Containerize with Docker. Deploy to AWS, GCP, or Azure. Monitor model performance and logs. This allows scalable and maintainable deployment.
Explain MLOPs briefly.
MLOPs is the practice of automating and streamlining the ML lifecycle, including data versioning, model training, deployment, monitoring, rollback, and CI/CD. Tools include MLflow, DVC, kubeflow, and Airflow.
You trained a model, but accuracy is low. What steps do you take?
Check data quality and clean errors. Explore more features or engineer new ones. Try different algorithms. Tune hyperparameters. Ensure proper train-test split. Use cross-validation. Add more data if possible. This systematic approach usually boosts performance.
What motivates you to work in machine learning?
I love solving problems that have real-world impact. ML gives me the tools to automate tasks, uncover insights, and build intelligent systems. I enjoy the combination of math, coding, creativity, and continuous learning.